Sketch the graph of f of x equals 3 raised to the x plus 2 power, subtract 4. State the domain, range, and asymptote. I see this as a transformation of the basic function 3 to the x. So I'm going to start by sketching that function. So let's consider the function, and I'll just call it g of x, just have a different name. Let's call g of x 3 to the x. And if we create a brief table of values for this function, maybe we go from -1 to 2 on the x's. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the negative first power, remember that's a reciprocal of 3 to the first, and so then 1/3. And if we plot those points, let's assume a scale of 1s on each axis. So then -1, 1/3 is about there, 0, 1, 1, 3, and 2, 9. And we see those points in the shape of an increasing exponential function. Looks roughly like this. And it's asymptotic to the x-axis, or y equals 0. Now, take into account the transformations. Instead of an x, we have x plus 2. And that's the same type of transformation we had in an earlier topic, and that says we need to shift left 2 units. All right, so for our f of x, we need to shift left 2 units. And then we have the -4. That is a vertical shift, or a vertical translation down 4. So let's shift down 4 units. So for f of x, the function, our goal function that we want to sketch, I'm going to take my x values and shift them left 2 units. I'm going to subtract 2. -1 subtract 2 is -3. 0 subtract 2 is -2. 1 subtract 2 is -1. 2 subtract 2 is 0. And I need to shift the outputs down 4 units. So I'll subtract 4. I'll do the easy ones first. 1 subtract 4, that's -3. 3 subtract 4 is -1. 9 subtract 4 is 5. 1/3 subtract 4. So let's see, that would be -3 and 2/3. Let's see, 1/3, let's do a little work here. 1/3 subtract 4. 4 is the same as 12 over 3, so that's -11/3. And we can think of that as a mixed number if that helps. -3 and 2/3. Okay, -11/3. Okay, so now plot those points, right? Those are the goal. Let's see, so -3, -1, 2, 3, and 2/3. So that's about here. -2, -3, -1, -1, and 0, 5. 1, 2, 3, 4, 5. All right, so also our asymptote, the original asymptote was at y equals 0. That's going to shift down 4 units as well. And so we get a graph that looks roughly like this. And it will continue on to the left. It will continue on to the right. The domain of the function is all real numbers. I'll write that in interval notation as -∞ to infinity. The range of the function. All right, so the range, the outputs, we can go right up to, but not include -4, and then we can go to any values higher. So the range is from -4 to infinity. And the equation for the asymptote, all right, so remember the equation of the asymptote, it's an equation, and the equation is, and we're looking at this line right here, that line is at y equals -4.